Alright, good morning, girls. Today we're going to go over section 3.7, graphs of rational functions. Talk about what a rational number is. Well, it's a fraction. So if we're talking about a function, it's a function that involves a fraction. So the parent rational function is f of x equals 1 over x. Now, when we were to graph that, you can always make a table in order to graph it, but just talking about a couple things before that, within rational functions, almost every one of them has an asymptote, which is a line that the graph never touches. There's three types of asymptotes, but the first two are vertical asymptote and horizontal asymptote. Vertical asymptote is where I like to say where x doesn't exist. And then the horizontal asymptote is basically the end behavior which we talked about the other day. As x approaches infinity, what is y approaching? So in this case, if we were to graph the parent function, we would graph, we can make a table. If I put, plug in 1 for x, I'd be here at 1, 1. If I plug in 2, I'd be at 1 half. If I were to plug in 1 half, I would be up at 2. So my graph is kind of going to do this number. As it goes along, if I were to plug in negative, it's going to go this direction. Now, if we're talking about asymptotes with this one, notice where's my x not going to exist? Well, if I plug in 0 on the bottom, I'll get an undefined number, so I'll have a vertical asymptote at x equals 0. And then as x approaches infinity here, y would approach 0, so I have a horizontal asymptote at y equals 0. For my parent graph. Alright, so first example, determine the asymptotes for f of x equals x over x minus 5. First one's really simple. For our vertical asymptote, we know x, we cannot have a 0 in the denominator, so x minus 5 cannot equal 0, so x cannot equal 5. So therefore, our vertical asymptote is going to be located at x equals 5. Horizontal, a little bit more challenging. Rather than having f of x, we can always make this y equals x over x minus 5. And to find the horizontal asymptote, we can just solve to try and get x by itself. So when we do that, we're going to make it y times x minus 5 equals x. I'm going to distribute my y to my x. So I have y times x minus 5y equals x. I'm going to switch. I'm going to move this x over and this y over. So now I have yx minus x equals 5y. I'm going to take an x out of both of these two terms. So then I have x times y minus 1 equals 5y. I'm going to divide this y minus 1 over, so I have x equals 5y over y minus 1. And now I can just figure out, well, what can y not equal? Well, y can equal positive 1, so my horizontal asymptote is y equals 1. Next example, we're going to use the parent graph to graph f of x equals, and really it's just y equals 2 over x plus 4 minus 1. That y really doesn't need to be there, but that is okay. So in order to graph this, first off we can talk about our translation. Down here it's like we're inside the parentheses, so that's going to tell us to move left 4 units because we do the opposite of what's on the inside of the parentheses. And then this negative 1 is going to tell us to go down 1. We follow what we do. And then lastly, this 2, that's going to be like a vertical stretch by a factor of 2. So now when we graph this, it's going to move left 4 from our horizontal, or from our original parent graph. So if we move left 4, that's like us having a vertical asymptote at x equals -4. Down 1, now we have a horizontal asymptote at -1. It was at 0. So now we can graph it. Again, we can plug in a number, like let's say we plug in -3. If we were to plug in -3, we would have 1 on the bottom, so 2 over 1 minus 1 would give us 1. So essentially, it's going to move everything up. I factor 1 with that multiplication, but in the end, the graph is basically going to look the same as our parent. It's just going to be stretched just a little bit. So that's just a little bit on section 7. Obviously, there's a couple other types of problems. We'll get into slant asymptotes for the next part, and I will explain that in class. But hopefully this will get you a good start. Thanks.